Hello guys, in this video lecture we will continue our previous topic. As you know, in the last video I taught you about the limit of function. So before starting today video lecture, I just want to recall you the previous lecture. In previous lecture we defined the limit of function. So first of all we recall what is the limit of function of two variable. Suppose fxy be a function of two variable is said to tends to a limit small l as x comma y tends to the point a comma b if for any given epsilon greater than 0 there exists a delta greater than 0 such that mod of fxy minus l is less than epsilon whenever mod x minus a is less than delta and mod y minus b is also less than delta. Then we say this small l is a limit of function fxy. We also used for this small l two terms. One is the double limit or simultaneous limit. And we write this simultaneous limit as limit xy tends to a comma b f of xy is equal to small l. Sometime in place of this condition we use whenever x comma y belongs to a neighborhood of point a comma b. We suppose it is delta neighborhood of a comma b. Then we say this small l is a simultaneous limit of function or simply a limit of function of fxy. Now we will discuss a new term related to limit of function. This is repeated limit. Repeated limits. Suppose f be a function of two variable, f is defined on a neighborhood suppose n of point a comma b and limit x tends to b exists, then the limit y tends to be f of xy is a function of x only. We say it phi of x. that is phi of x is equal to limit y tends to be f of xy. Now if limit x tends to a, phi of x exists and equal to some value, say lambda, then lambda is called a repeated limit of fxy as y tends to b and x tends to a. X tends to a. And we rewrite this as, and we write as it as limit x tends to a, limit y tends to b f of xy, and this is equal to lambda. If we change the order of limits in, this is equation first, in first, then we get other repeated limit of fxy at point a comma b, and then this, after changing the order of limit, we get y tends to b, limit x tends to a, and f of xy, we say this is equal to lambda dash. Here it is noticeable that the value of lambda or lambda dash may be equal or not. It is not compulsory that both the values, that is value of lambda dash, will be equal. It will be equal only when, number first, number second, if simultaneous limit exists, then the repeated limits, that is lambda